Thank you so much for joining me. It's a real privilege and honor to be able to present to you guys. It's really exciting to be speaking to people in America and all over the world. So that's really exciting, and I hope that we're able to help you think about, we'll show you at least what we're doing with data for community action in Australia. So we're going to talk about three of the models and the projects that we've worked on in the most recent sort of months of Seer. The population forecast model, a service availability model, and the intergenerational wealth transfer modeling and estimation. And hopefully a little bit about why each of those are very exciting and what people are doing with them now. So firstly, population forecasting. This is very sort of traditional bread and butter analyst and demographic modeling type of work. But really quickly, sort of why is population forecasting useful? At a community level, population forecasting is really useful because it helps and underpins a lot of planning activities. Most councils, most municipalities, governments, but also service providers in the private sector as well need to know what their population is going to be doing, the population that they serve in areas where they're located, how that population is going to change over time. Utilities also find that kind of information very important, as well as businesses. Typically that service availability that they're going to want to provide for is going to be based on a population plus a bit of buffer, and obviously scheduling for the particular business model. But that's really important and why they're needing to do that. You can see on the right-hand side the population forecasting based on a whole different range of model projections there from the United Nations. And there we are in 2020, just cresting the 8 billion mark, which is a crazy number of people to have on this planet. I'm hoping to hit the next slide button. Here we go. Great. So traditional methods of population forecasting involve putting together a handful of heuristic models into what we call an empirical model that takes account of a few different factors, and we sort of define those factors up front and then describe how those factors are interacting in a particular location according to a mathematical model that we, again, define up front. Those factors tend to be things like birth, death, and migration. So kind of simple flow rate model, if you like, how many people are arriving, how many people are leaving, and what are the various modes in which they're doing that. And then essentially what those different factors will do is they'll describe or determine the way a population is going to evolve over time. And what you'll see is that as that population evolves, it will take on a particular characteristic shape in terms of the population pyramid for that area. You can see a handful of those different types of population pyramid then at the bottom of the slide there, where those different characteristic shapes will have different stories to tell about how that population is evolving over time, what to expect, and how that population is likely to shift and change next. It's obviously also going to have a different envelope and need for consideration of different services that are going to need to be available for those populations, and ways in which we can anticipate the needs of that population and how we can meet those needs, whether we're government or private sector service providers. So a bit of math to just describe exactly what I was talking about, where we're saying these traditional models typically are a very simple equation that take account of what the population is. If we're estimating the population tomorrow or at time t+1, then we're taking the population today, we're adding a number of people who are being born, we're subtracting a number of people who are dying, we're adding a number of people who have immigrated and subtracting a number of people who have emigrated, and that's essentially what the population is going to look like tomorrow. Very traditional model, that one. And we contrast that with the approach that we've taken using a machine learning approach here, where at a time t+1, essentially we're saying that there's some function which is going to take in the population today and the population perhaps yesterday as well at t-1, and that function is going to produce for us the population tomorrow, or t+1. And the task of machine learning in classical terms is to find f, or define f, use machine learning techniques to work out what that function actually is that's going to map that historic population to that future population. So the appeal of machine learning over the traditional methods really is that we need to spend less time digging into the key or the very specific on the ground factors of a particular location to estimate those various rates. We don't need to build those rates into our model, because our model is going to learn what the important things are to watch out for when predicting our future population. Each of those things that go into that traditional or empirical model, we call those assumptions. So we assume a certain death rate, and see what the population is going to do on that basis. And where you saw on that first slide where that population forecast and projection was diverging into the future, essentially that's like just a range of different birth and death and emigration rates. There's very little immigration and emigration from the planet Earth, but that would have been the sort of analog, I guess, of that slide. The disappeal is really that what we're assuming up front is that there is enough information encoded in that historic data or in the data that we're feeding in about how populations are going to move and change to give us the right picture about that future. So that is to say that there is a sensible F that we can define on the basis of historic data that's going to map the past population into the future population. So we do make that assumption, but then we can train and test our model to estimate how well it's likely to do and to minimize the loss that it's achieving on that data set. So some notes on the available data, this content really was prepared for an Australian audience, so I apologize, I'm going to reference a thing called an SA2, but that's like a suburb you can think of. An SA2 is kind of like how our Australian Bureau of Statistics likes to describe areas that are about the size of a suburb in Australia. And so essentially we chose SA2s as the region that we were going to use as the basis for our modeling. The reason for that is that users or people who consume the kind of information that we're talking about tend to have a sweet spot of that population and area size that they're interested in. Typically our users who tend to be, and this is of the Seer platform, and Christy probably spoke a little bit about the Seer platform. So hopefully you're able to sort of just as we go along, but I can also always answer questions as well. Users tend to have an interest in understanding their local context, where local really means, large enough to encompass a population that is sort of big enough to be of interest. So we might be talking about a municipality, or maybe we are talking about a suburb, but not so small that the detail becomes super noisy and difficult to summarize, or that there's not much signal to the noise ratio, if you like. SA2s are a good fit for that reason. Machine learning also requires a lot of data typically, and that's because that F that we're finding, we tend to start with a potential for the machine learning model to take on a lot of different parameters to tune and refine a picture for what that F looks like. And so where there are a lot of parameters, there's a lot of opportunity for the model to do what we call overfitting. And that's where the model essentially begins to just memorize the training data that it's seeing, rather than actually learning about the patterns that are exhibited in that underlying data set. So we're looking for an area type that's going to give us enough training examples. So we need a lot of them, but obviously the more training examples, the more areas we break Australia into, the smaller the populations in each one and the noisier each particular population becomes. So for that reason, SA2 seem to be about the right trade-off. Some notes on the available data here. You can see there's just a little bit of a breakdown of a couple of different areas. On the left-hand side, we've got histoplots over all SA2s. These are distributions over the population of SA2s by population size. So along the horizontal axis is the population size, and in the vertical axis on those charts is how many of those SA2 regions have a population of that size. And we've got that for 2016 at the top and 2011 at the bottom, the two most recent census counts that were taken in Australia. You can see there that in both of those years, and this is by design by the ABS, the majority of the largest number of SA2s have a population of around 5,000. That's the modal or most common size of a population, with an average of probably in the vicinity of 10,000 people. So that's the size of the population that we're modeling when we're producing the results of this model. And on the right-hand side, you can see breakdowns by age. By age across the horizontal axis, by gender in terms of the red and blue. I think red is is female and blue is male. And then the dotted line that you can see where there's that dotted line type, that's for the year 2016. And the hard line or the solid line is for the year 2016. I might have said 2016 twice. I know 2011 and 2016 respectively for the dotted and solid lines there. So you can see that's for two different areas. The one at the top, Glebe Forest Lodge. This is an area that's sort of in the urban, densely populated region of Sydney, where you tend to have a high proportion of people in that 25 to 29 year age bracket, where young people are flocking in towards the cities to find employment and get their careers up and running. And in Berry Kangaroo Valley, this is a more of a regional area where you tend to actually have a bit of a slump around that. It's kind of the inverse, if you like. You get a slump around that 25 to 29 year age bracket. And then over on the right-hand side, where we're in the sort of 65 years and over, you've got a much larger population there of people who are retiring and reaching that age. And you can see just based on that dotted to solid line transition, there's a little bit of signal there indicating that in the case of Glebe Forest Lodge, we're getting a little bit of an uplift in that 25 to 29 year age bracket, a growth in that area. Whereas in the Berry Kangaroo Valley, we tend to see that older age bracket is marching forward in time and tending to age in place. So there's a couple of different just factors you can pick out that a human will just identify sort of reading this information. And at the bottom there, just a note that there's about 4,000 records available in the whole data set where we're able to take historic census data and build up our data set. So the architecture of this model is a neural network. We experimented with a few different model types, a variety of different depths of network, and found that a shallow network was giving us as reasonable or as high results as any of the sort of much deeper models. And so what we did essentially was to train an ensemble of 10 of these single layer artificial neural networks. And what that does is then it takes, each one of those networks takes the 2011 or takes the past 2 years worth of census counts by age and sex, if you like, as the input to that model. And then what it outputs is the count by age and sex for the next or following census year. So it'll take 2011 and 2016 and output 2021. And the nature of that kind of a model is that it's what we call autoregressive. So that means that essentially I can take that input and I can slide it across for one census year. And I can then take the 2016 and 2021, so the 2016 historic and the output from the last round of 2021, add those together. That's going to produce the 2026 population there. So that's the nature of the model and a little bit about the architecture. And this is what the results of that model look like. So we can see here that on the left-hand side, we've got the two charts that both speak to the Glebe Forest Lodge SA2. And you can see that the model here is picking up on that very sort of more subtle signal that we sort of identified really briefly in the previous slide, where we're getting that uplift in that 25 to 29 year age range. That's really accelerating over time. What the model's also predicting is that where you see that uplift in 25 to 29 year age bracket through to sort of mid-30s, we're also going to start to see, if you look on the far left-hand side of those, and apologies, the horizontal axis is not labeled here, but this is over the age range for that area. On the far left-hand side, where you can see that those red lines stepping up, that's indicating that the age range of 0 to 4 is also stepping up, and that's commensurate with the number of people in those areas who are, of that sort of young family age. We can contrast that with what the population of the Berry Kangaroo Valley SA2 on the right-hand side is doing, where you can see that, again, that population in that 65-year plus age bracket marching forward, aging in place, and in fact that the most common age for that location is probably moving from about that 65 through to about 75 or 80 year age range. And so there are very different stories that these different areas are telling about how those populations are going to evolve. And this is really important information for, as we said, councils to have to understand the availability of services for these very different types of demographics. It's not just about how many people are we going to have in our location over time. It's not just an aggregate figure that a water utility, for example, might need to know about to be able to predict how much water people are going to need, or things of that sort. We can get much more nuanced and detailed about what the needs are of that population. So, service availability. This is a model that we built some time ago and refined for the Logan Together organization, who are oversee the outcomes of the people in Logan City, which is in Brisbane, in Queensland of Australia. The idea is that Logan Together wants to give children the best possible start in school that they can. So they want to make sure that the kids are as ready to learn and ready for school as they can be when they arrive for their first year of school. In Australia, we've got this data set, or I should say, a measurement framework, an evaluation framework, or a predictive framework called the Australian Early Development Census, which is an instrument that we use to understand how developmentally vulnerable or how developmentally ready children are when they arrive at school. And the part of what the AEDC recommends areas look at for ways to improve the developmental readiness of their children is providing access to quality early education, early childhood education and care facilities, so preschools, for example, childcare and child-minding services. So what we did was we worked with the Logan Together organization to develop a mathematical model of Logan City and surrounds, which is going to help to identify where and why more high-quality services might help. And so what this model is going to do is it's going to look at where the services are throughout the region and where the populations are. They're going to be seeking those services, say children aged 3.5 to 4. And that's going to look at where the balance of demand might be exceeding supply and so forth. So we can have a quick look at that model just now, actually. I'll pull up the live model and show everybody. There we go. I think it's going to let me do that. So, great. So can I ask, can everybody see the map that I'm just showing on the screen right here? I hope everybody can see that one. Okay. Oh, that's cool, Jay. I just saw you give me a thumbs up. I didn't realize it was going to let me see that. That's cool. All right, so I'll just turn off a couple of things on this map so that we can talk about what is shown here. So what we're looking at here, if I zoom out, actually, you can see a little bit more of the Australian context. So this is where we are in Australia overall. Gosh, Australia is a big country, isn't it? So here we are in Australia, and we're in this location here, just on the far southeastern corner of the state of Queensland. And what we've done is to draw a circle around an area that encloses the municipality of Logan City. So apologies for the sort of jumping around on this map a little bit. But you can see here, within this part of the map here, within this circle, which we call the analysis area, we've got the local government area of Logan. And each one of these little areas that we've got colored in this choropleth, we call it, where they color these little areas that are on the map according to some data. Each one of these little areas is an SA1, so it's actually a little bit smaller than an SA2, so it's more like a couple of city blocks, if you like, type of size. And what you can see painted on across that scale here is the density of children per square kilometre, and that's children aged 3.5 to 4, the density of children per square kilometre in each one of those locations. If I hover over one of those locations here, for example, this one is located in Chambers Flat, and there are 38 children that we've been able to find from census information as to where those children are located throughout this region. So census information is one of the key inputs to this model. The other one is, if I find the providers, there they are. Great. So I'll just turn on another layer here, which is those markers that we now see on that map. Each one of those markers represents a provider of early childhood education and care. So this one here, the name of this provider is deadly Kindi Baraga. I hope I'm pronouncing that right. And you can see here that this type of service that it is, it's a centre-based care. It's working towards the national quality standards. So the data set that we're working with has an overall quality rating for each of these providers, and that's the quality rating. And it's approved to receive 23 children on any given date. That's the number of approved places. So you can sort of get the idea of what this model is trying to wrestle with here. We've got the distribution of children across this map. We've got the location of the providers. We've got how many children and how many approved places, and we're trying to understand, where the balance of supply might be over the supply of the demand. Sorry, a bit clumsy in that language, but I hope that you get what I'm driving at there. What this model is attempting to do is to work out the proportion of children in each one of these locations that are attending each of these providers in order to minimize an overall objective, which is made up of 3 parts. So that objective is made up of trying not to make children travel too far to attend their provider, trying to make sure that children are attending a provider that's of highest possible quality, and trying to make sure that children are attending the provider that is able to receive them, so that the providers aren't totally overutilized and crowded, and children just miss out in that case. So it's using techniques from machine learning to minimize that overall loss or penalty and find that overall sort of best case scenario of allocation of children to providers. And when it does that, then you can see this layer here that we're showing in this choropleth now is an overall degree of residual need. So this is where, over those 3 factors all at once, where are the areas that are still experiencing a hard time finding a place for their child to attend that's of high quality nearby and not totally overcrowded. If I turn on this proportion assignments layer with these red lines, you can see this is for each one of those SA1 areas where the model is saying the highest proportion of children from that area is attending which provider. And if I zoom in on the middle of this map here, and you can see a little bit more detail about which providers are receiving children from which locations. So that's interesting for sort of learning, if you like, the natural catchment boundaries for those providers, and why, and we can dig into why it is that certain areas are corresponding to different types of need. So those three need types, distance, quality, and capacity, are also articulated in different layers here, where we can explore the degree to which, in this case, distance is contributing to that overall degree of need. You can see here that, for example, we've got a handful of kids in this region in here where we're now seeing a deep red color. That indicates that children in those areas are having to travel a long way to attend a provider. And you can see that's borne out by the length of the red lines that are joining the children in those areas to the provider that they're allocated. The reason that these children in that area, for example, are having to travel a long way to find the provider, the model is also able to articulate, is because of a capacity deficit, an overall capacity, a need for more capacity, so more approved places at the providers in their location just adjacent. So what's happening is that these kids in these areas are having to go further afield. They're escaping that capacity deficit at the cost of having to travel a great distance. And the model is saying that based on treating each of those factors equally, that's what's most likely to be happening in those areas. Finally, the quality of the providers is also able to contribute to that overall degree of need. And so what you can see here is that, particularly in these some of these more central Logan areas, some of these providers here which are working towards the national quality standards as opposed to exceeding the national quality standards. The children in the areas where the model is saying those children are going to be attending those providers, they're going to be suffering a quality deficit. And so those might be areas where more investment might be needed for more high quality services. Cool. So I'll swap back to the slides now. Cool. All right. Last of our three models. I've only got 5 minutes left, so I apologize. I hope I'm able to get through everything that I need to with this one. Transfer of wealth. So, and actually this is interesting. This is based on some work that was originally done in the United States, which I'll get to in a second. Just to be very clear, what we mean by transfer of wealth is that in a particular region where a household, where the parents in a household might pass away or might be ready to transfer the wealth that's accrued to that household from one generation to the next. That's essentially what we mean by transfer of wealth. Why this is an important question is that there are many philanthropic and community foundations who rely on donations to do what they do and support their work. Part of those donations come from bequests and other structured giving vehicles that are typically associated with an estate, and often those donations occur, when that estate is passed on, and the executor of that will, then makes that determination. So that's essentially what we mean. That's the definition of transfer of wealth that we're working with. And the work that we have done is with an organization called Into Our Hands in the northeast of Victoria in Australia. It's a community foundation, and they were inspired by the work that was done by the Nebraska Community Foundation in the US, building on work that I believe that was done by the Boston School of Economics, actually estimating by location again the transfer of wealth within households in the US. So the Nebraska Community Foundation picked up that work, particularly, I think it was spearheaded by, you can see that fellow Don Mackey. And then between 2001 and 2006, the Nebraska Community Foundation were able to grow their endowment, their funds under management from 10 million to 28 million, which is an enormous effort and a really great success. And that was recognized by Into Our Hands, and their thinking was, how can we replicate that work in Australia? Can we see similar results for our community? This is what their campaign looked like by the Nebraska Community Foundation. Turn up your dream switch was their catch cry, and their sort of marketing slogan, if you like, or the way that they took that preposition to their community and said, hey, listen, if you're willing to think about structured giving and willing to think about potentially leaving an amount in your will or an amount from your estate to the Nebraska Community Foundation, this might be what we'll be able to do with that money. We'll reinvest it back into our community and improve outcomes and improve living conditions. Similar work undertaken by in Kansas, I should say, with Keep 5 in Kansas. I think there's some similar work now based on that kind of messaging going on within the sort of central Victoria or Melbourne areas. And so, yeah, we've got our eye on the way community foundations are doing it in the US as to how we can do that here in Australia. So we met with Into Our Hands and learned about what their ambition was. They pointed us in the direction of the work that was done by the Boston School. And we had a look around to see if we could replicate that work here in Australia. There's a little bit of information there about the region that Into Our Hands was focused on and the populations within those regions. We built a methodology for replicating that work based on the public and open data that was available in Australia that was kind of analogous or equivalent, where we could find it to the data basis that the Boston School was working with in the US that they published. And so I won't go into a great deal of detail on that methodology, but suffice it to say that it was really geared at the same outcome. We're trying to understand what the total quantum of wealth by location around Australia is going to be and forecast that transfer in 5-year increments, as you can see here, out to 21 to 2066. And what you can see here is that breakdown across that region that we were seeing just in the northeast of Victoria, where by 2041 to 45, in that 5-year increment,
there's going to be about $2 billion, or just north of $2 billion overall transferred within that region, which is huge. This is a part of Australia, part of Victoria and Australia that of themselves would not have thought of themselves as, you know, a particularly wealthy region. It's not somewhere that many Australians would think of as being a place of considerable wealth. But when you look across a region like that, you aggregate up these figures, you get to some pretty large figures, and it's quite inspiring. And that was really a great outcome for them, and part of something that's helping them to get their communities excited about structured giving and bequesting. So our work was also put together into a report that you can see here, breaking that down again by 5-year brackets, I should say, across each of those regions. And we can also we're also able to break that down by age bracket, or reference age of the household. So you can see their sort of negligible wealth transferring up until that 55 to 64-year age range. And to few people's surprise, the 75 plus age range is taking up the majority of that wealth that's transferring, and how that's shifting over time. And interestingly, you know, by gender, how much of that wealth is transferring as well. Finally, we were able then to turn that into something of a business model, a business case for them, if you like, talking about for their region, based on different rates of participation and different percentages of the estate they were able to, or could be able to convince people would be suitable to leave behind. What would that mean for their endowment over time? So that's all. I hope if anybody has any questions that they'd like to ask, we might have a few seconds. And I apologize, I might have gone a minute or two over time. But yeah, I'll be here if anybody would like to ask some questions. If not, of course, thank you so much for joining me. I've appreciated all your company. I hope that some of that was interesting and useful. If you can see opportunities or ways in which you can adapt this work for your own circumstances, then that would be really exciting. And we'd love to hear about how you're doing that.
Hi, can you hear me?
Paola,
Hello.
yes.
Yes, I have a question. How do you find, I really like your visualization on the map. Was that easy to convey when you bring it back to the council and to the city and the people who are gonna use it? How do you find the communication between explaining them how a machine learning model works and how these visualizations works and the actual use, like how do they take on into these tools and actually use it? Is it very complicated, or was simple? Like, what's the intake of the audience?
Yeah, great question. So I would probably say that, well, so firstly to just let you know, that map that I showed on screen, that's essentially a file that we generated as part of the output. So it was kind of like an interactive report, but it's a geographic map, obviously, that you can dive in and out of. But that file, you just transfer. That's a large file size, so it's not going to be easy to transfer as an email attachment, but you could pop it in Dropbox or something, and then it's there, and then the council or the community organization can open it up and play with it whenever they like. And as such, it's really that map, the most important part of presentation of that map was, I think, teaching the council and the organizations that are going to use it how to use it. And that means how to navigate it, how to move around the map, how to dive in, what each of the example little reports mean. So we say approved places, what does that mean? But we're talking about utilization rates, what does that mean? And how to read and interpret the map. We did pull out a handful of observations, I guess, across that map that we found interesting, and compiled those observations into an introductory methodological and results-oriented report, like a more traditional report, which kind of, as I said, pulled out a few of those interesting observations. But I think really, yeah, the philosophy with that output was that it's such a rich output. The point of it was that it's wrestling with a situation, it's wrestling with a data set and a circumstance or a context which is so rich in complexity and detail that you kind of need to give people the opportunity to dive in, pan back, and interrogate it at a lot of different length scales. And there's going to be local context that those people within those areas who have that domain knowledge are going to have about how to interpret that information that we don't necessarily have, as we don't have that domain knowledge. So it was really about training them in how to read and understand how the map came together and how to drive it and use it. Yeah.
Thank you.
No worries. All right. Well, that was wonderful. Thank you so much, everybody. If anybody else has any other questions, then by all means, let me know. I'm just checking the chat here just to see if there are any questions. Thanks, Priya. Yeah, it would be fascinating to apply this work to some international contexts as well. Yeah, that would be great. So if there's nobody else has any, I might wrap it up there. Thank you guys again so much for joining me. And if you've got any questions that come to you later, then by all means reach out. I think you're able to get my email address or reach out to me on LinkedIn if you'd like. That's all totally cool too. So thanks very much again, everybody. Have a wonderful afternoon, morning, evening, wherever you are. I'm not entirely sure. It's afternoon here, but you never know. Have a great day, and I'll see you soon. Thanks.